Hello, welcome in my tutorial which name is TechPod. Today we learn variable and data types. First is variable. Variable is a data name that may be used to store the data value. Okay, it means variable is a data name. It means I want to store any value. Before storing the value, we must define the variable, and variable name is defined by the programmer. Some example of variable: add number, class number, first name, my city, and so on. We can easily identify by variable name. What is the use of variable? First example, add number. It means I want to add some number in this variable. Then class member. It means I want to define the class number in this variable. First name. It means I want to know first name from the user by console. My city. It means my city name, and so on. For example, I take one example. I have defined three variable and data type is integer. First is my first number, second is my second number, and third is total. It means I can assume based on this variable my program may be first I take the first number from user, then I take the second number from user, and finally I define the total. But some rules are for defining variable. They begin with letter. Some systems permit underscore as a first character. For example, its first letter is always alphabet, not digit. It may be in lowercase or it may be in uppercase, but some system allows underscore as a first character. ANSI standard recognize a length of 31 characters. It means ANSI standard recognize our variable name must be less than 31 character. But we take many example in our programs, but our program in our program variable name should not be more than the 8 character. Since only first 8 character are treated significant by many compiler. It means what? Most of the compiler use the first 8 digit to identify the variable. And next rule, compiler treat uppercase and lowercase are significant. It means uppercase ABCD in second variable. First A is uppercase and B, C in lowercase, and third in all character are in lowercase are not same. Compiler treated all of by different behavior. It means this ABC and uppercase small bc and small abc are not same. Next, its next point, we do not use the keyword like for, while, struct, and so on. It means if I define, for example, integer and while. So while is a keyword in C language, and this keyword is reserved for a while loop. So we don't use this keyword here. Now I try to run my program. It generates the error. Error here, yes, unexpected identifier or start branches before while. It means a compiler treat as a while loop, not a variable. Next, white space is not allowed. It means if it means I want to define name like this, add space number. It is not verified by compiler, and it contains the error. So these all are the variable rules how to define variable in our program. The next is the data type. Storage representation and machine interaction to the handle constant, different from machine to machine. It means storage representation. Storage representation means what? How to data stored in our machine are treated as different as for the compiler. C language support three class of data types. First is primary or fundamental data type, second is derived data type, and third is user defined data type. Primary or fundamental data type we discuss in this chapter, and derived data type and user defined data type we discuss in the later chapter. So first, now we take quickly overview of the primary data type. First is integer. Integer are whole number with range of value supported by particular machine. It means integer is a whole number, and this type of data have some particular limit. Storage capacity for 60-bit machine and 32-bit machine are different. 16-bit machine can store the data in range -32768 to 32767. Significant integer use 1 bit for the sign and 15 bit for magnitude, or we can the store of number. Now we take practical example. It means integer contain 2 byte. 2 byte means 16 bit, and our compiler treated different as per the storage capacity. It means 16-bit compiler capacity is less than to 32-bit compiler. For example, if you have 32-bit compiler, then your range is -32768 to 32767. Now I use the one variable a and initialize the value 32565. It means this value is more than this range, so it's contain, then what? It's contain the garbage value. But in my case, my compiler is 32-bit. It means my compiler range is here, 21474836482 plus 21474836447. It means I take one variable and I store the some value which is the outer of this range. Then what? First I try to print this. So I take printf, an integer, so I take %d here, and then I print a. What happened? It take the garbage value, not this specified value. Now I run my program. Look at this, -17066. It is, this value is not our value, because our value is 3, 2, 5, 4 and 5 so on so. But compiler gives the output -17066135533. It means what? Our value is outer of particular range. C has three classes of integer storage, namely short integer, integer and long integer, in both signed and unsigned forms. For example, short integer is the less capacity to compare long integer, and we most of the people use the averagely integer. Next is floating point types. Floating point types, or we can say real number, are stored in 32 bit with 6 bit precision. 6 bit precision means what? 6 digit after point. 6 digit after point. Now I take one example. For example, first I remove this integer number, then I take data type as float. Then I use one variable a and store some number in this variable 5.5, and I use percentage if because my data type is float. Then I run this program. Look at this. After point 5 digit is come here. So this 5 digit is called precisions. In my case, my variable is just I contain 5.5, but the compiler gives the answer in 5.5 and after 50. It means after point he take the 6 digit as a precisions. Then when the accuracy provided by float number is not sufficient, the double can be used to define the number. It means I want to answer in most precisions as more accurate way. Then float is not enabled to fill our requirement. At that time we use the double, because double gives answer in more precisions. It means we can say more zeros or more digit after point. Double data type number use 64 bit with 14 precisions. It means float contain only 6 precisions, and whenever we talk about double contain 14 precisions. It means float and double are both same, but double represents same data type with more precisions. Clear? Then we also extend precisions with the use of long double with use 18 bits. If we want to more and more accuracy, or we can say we want to work at the scientific level, at that time we use the variable as double, which contain 80 bits. Next is void. Void is also contain the type. In this type has no value, which is specify the type of function. The type of function is said to be void when it does not return any value to the calling function. For example, I define void here. It means my function is main. Main is also user defined function. Then my main function does not contain any calling value. It means my calling argument is 0. And if I use integer here, it means my return type is integer. It means after finishing the work of the main function, some integer values come here. And if I use the void also here, it means my program doesn't return any type of value. Void. Clear? Void is also called a type. The next is a character type. Single character can be defined as a character type data. It generally in 8 bits or storage. For example, I use character data type. Then I use one variable a equal to Okay, I use variable b equal to k. Okay, it means what? I define one variable b which contains the one character. If you want to initialize the character to b, always use the single quote bracket, not a double quote bracket. This is the difference between character and string. String means if we want to store the more than one character, and at that time we use the double quote here. Clear? The qualifier signed or unsigned may be explicitly applied to the character. It means we can also use the signed character and unsigned character. By default, it is a signed character. While unsigned character have value between 0 to 255, and signed characters value from, or we can say limit of signed character is minus 128 to plus 127. Then I given you one table which contain the memory and the range. First is the size. First is the size and range. Size and range of data type of 16-bit machines. It means this all the byte and all the range contain the range contain the 16-bit machine, not 32-bit. It means if your machine is 32-bit, so you can also cross this limit, or we can say you can also value more than this range. So in our case, first is character which contain 1 byte and range is 128 to 127. Next, unsigned character. Unsigned character also contain 1 byte. 1 byte means 8 bit, and also contain range 0 to 255. Then signed character. Next is signed character. Its byte 1 and range minus 128 to plus 127. It means if you do not define as unsigned, by default it is a signed. It means this unsigned signed character and this character both are same. Look at this. Memory is also same and range is also same. Then next is integer. Integer contain 2 byte, and this is the limit for the 16-bit compiler. Range is minus 32.8 to plus 32.767. Okay, and then unsigned integer. Unsigned integer contain 2 byte and range is 0 to 65535. Signed integer memory 2 byte and range is same as the only integer. It means minus 32,768 to plus 32,767. If you do not define the unsigned keyword, then by default it is signed integer. Then short integer. Short integer contain the 2 byte and the range is minus 32,768 to plus 32,767. Same as signed integer and only integer. Then unsigned short integer. Unsigned short integer contain 2 byte and range is the 0 to 65535. Then short integer, signed integer. Okay, signed integer come here 2 times, so okay, forget this line. Then next is the long integer contain the data more than integer. Look at this, the range of integer, and look at the range of long integer, which contain 4 byte. Then next is a signed long integer. It is also contain 4 byte, and this is the range. This is the range of data. Then next is the unsigned long integer. It also contains the 4 byte, and this is the range of unsigned long integer. Then a float, which is main used to store the data with precisions, or we can also say real, contain 4 byte, and this is the range. 3.4 is 4 is nothing but we can say in scientific notation. Then double, contain 8 byte, and this is the range of double. Then last is long double, which contain 10 byte. And we finish here our data type, and now we take one practical example. For example, first I remove these all things. Okay, then I declare some variable. First is a float. X equal to 1.23456789 9 and 10 11 12. Total digit is 10. Then I want to print this number. So float, I use percentage F here, 10. I print this number. Look at this output. First I debug and compile. Output is only 1 2 4 5. Okay, I am missing the 3, 1 2 3 4, and I remove 1 0. Okay, output is 1 3 4 5 and 6, not 6 7, because your after precision value more than 6 digit, next digit is more than 5, so it can take automatically increment the 6 precision digit. It means if I use here 2, then what, my number is not more than 5, so my output is 1 2 3 4 5 6. Look at this, 1 2 3 4 5 6 7. If I use 7, it means my after 6 precisions my digit is more than 5, then it increment automatically. But question is here, my value is 1 2 3 4 5 6 7 8 9 0 0, and answer is only 1 2 3 4 5 7. How to print this number? Because float by defaultly take the 6 precisions. So if I want to print whole number, so I use point and 12. It means I want to print 12 number after point. Then I compile and define. Look at this, 1 2 3 4 5 6 7 8. Again problem is here, because after 8 next number is 8900. So come here, where is our float? Yeah, it means after 9 6 7 8 9, next number is 35747. So float automatically increment the previous number. Okay, I simplify using the notepad. For example, after point 1 2 3 4 5 6. Okay, float give the by default by by default plot precisions. Okay, now I want to value this time 1.1234567. Now compare this value. This value is more than 5, then plot increment here 7. Okay, then if I use 1.1234566, I forget. Okay, 6, I do not use 6 here, and I use here 8. Then what? 8 is come here because my next value is more than 5. Clear? This thing is happened here, nothing else. Then now I use the one variable as double. I use double. Okay, then is in this double I take one variable as a y, and I store value 1.123456789. Okay, then semicolon, then I print the y. Control C, and I use here y. And if we want to print the y, then not use the only f but lf. Okay, now I try to run my program. Look at this output. Okay, /n I define here because I want to output in next line. Okay, then what? Look at this. I use number 1 2 3 4 5 6 7 8 9, but my double variable give us a result 9000. Clear? Because double contain the more than precisions to plot, because plot contain only by default 6 digit, or we can say after point 6 digit, but whenever we talk about double contain the more precisions than plot. Now are you clear with all data types? If our requirement is small, then we use the small integer if our number is in digit, and then our requirement is high, then we can also use the plot double as per our requirement. So I think, are you clear with all data types, how we use the data types? And in our next lesson we take one program. In next lesson we take one program which use the all data types, and we take the all values by default, and then we print all value as per the data types. So okay, thank you, bye bye.